Hello, fifth graders. This is Mr. Page. I am going to be presenting you today the final outbound distance learning lesson for this year. And this one is a recap and a review for our final quiz, our final exam. Today, we're going to be talking about elements and compounds. The elements are matter, they have mass and take up space. And as you know, that's the definition of matter: anything that has mass and takes up space. That's what makes them matter. Elements are matter, but they are not living things. Let me say that again. The elements in the periodic table are matter because they have mass and they take up space, even gases, but they are not living things. We learned that the atmosphere itself is made up of three elements: nitrogen, 78%, oxygen, which is 21%, and the remaining 1% is made up of carbon dioxide and other trace uh, gases. Now, the elements fall into two categories. They can be described either as solids, liquids, or gases, and they also can be described as metals, nonmetals, or metalloids. For example, iron. Iron is a solid. It is also a metal. Take another example: hydrogen. Hydrogen is a gas and it is a nonmetal. So each of the elements can be described by both of these categories. Now, here's the periodic table, which we should all be familiar with. It contains all of the known elements: gases, solids, and non-metal metals, as well as metalloids. And the metalloids share properties of both metals and nonmetals. What is an atom? Well, an atom is the smallest particle of any element or matter. It is the smallest building block of matter. You can't get any smaller representation of matter than an atom. Atoms make up all matter. Pick an element from the periodic table. Here we have iron. Here's the symbol on the upper left block, and its atomic number is 26. It is the 26th element shown in the periodic table. Iron, that comes from the Latin word ferrum. That's where we get the Fe from. The atomic number, as I mentioned, is 26. And that number, 26, in the upper left hand corner of every element, it is the atomic number. It's the number that it appears on the periodic table. And it's very important because it also tells you how many protons with a positive charge and how many electrons with a negative charge that element has. That number identifies both the protons and electrons. And because the protons and electrons are the same, you have positive and negative being the same, so they cancel out one another as a charge. So the atom has an overall neutral charge. To find the number of neutrons, it's a little bit different. You take the atomic mass, which is at the bottom left hand corner of the atomic number in the periodic table. And for iron, we have 55.845. And then you round it to a whole number. And since that has 8/10, then we round it up to 56. If you remember your rounding principles from mathematics, 5 or above, give it a shove. 5 or below, let it go. So we take the number, the atomic mass 55.845, round it to a whole number, which is 56. Then we subtract the number 26, which is the atomic number. So 56 minus 26 gives you 30 neutrons. So iron has 26 protons, 26 electrons, and 30 neutrons. Let's take another example. Nickel. Nickel, symbol Ni, is the 28th element in the periodic table. It tells you that it has 28 protons, 28 electrons, and if you round the atomic mass 58.693, you get 59, and you subtract the number of protons and electrons, which is 28. 59 minus 28 is 31 neutrons. Here we have carbon. Carbon has 6 protons and electrons, and it has 12 minus 6 neutrons, which means it has 6 neutrons. Take a minute and check that. Give this one a try. Oxygen. Atomic number 8, symbol O. Oxygen has 8 protons and electrons. And take a minute, stop the video, and see if you can figure out how many neutrons it has. As you can see, it's got 16 minus 8, or 8 neutrons. What is a compound? Well, a compound is 2 or more elements bonded together. An example is water, H2O. 2 elements bonded together, hydrogen and oxygen. Some compounds are made up of several elements, more than 2. What is another compound? NaCl, common table salt. What are the 2 elements? Sodium, which is a metal, it's a soft metal, and chlorine, a green gas. Bonded together as a compound, they become a brand new substance called salt. This is the result of a chemical reaction. Reactants and products. Reactants are the elements or compounds you start out with in a chemical reaction. For example, the process of photosynthesis, shown as the example. You have 6 carbon dioxide molecules and you have 6 H2O molecules. Those are the reactants, and they're always shown on the left. That's what goes into the chemical reaction. And then, as the products of that chemical reaction, we have a compound. We have glucose, C6H12O6, and also a gas, oxygen. Those are the products of photosynthesis. Products are the elements or compounds that you end up with in a chemical reaction. So, again, the reactants are what you start out with on the left, and the products are the compounds or elements that you end up with on the right. What is conservation of matter? This is the scientific principle that matter is neither created nor destroyed during any physical or chemical change. Conservation of mass is very similar. Mass cannot be created or destroyed either. in a physical or chemical reaction. For example, when wood burns, the mass of the soot, ashes, and gases equals the original mass of the logs and the oxygen when it first reacted. So the reactant mass equals the product mass. Conservation of mass. Well, that's it, guys. Till next time, feel free to watch this again if you need to. Be sure to complete the assignment and the quizzes associated with this lesson. And remember, throughout the summer, learn something new every day.